In this section, we're going to look at more sequences and patterns. Section 1.2. The first type of sequence is arithmetic sequence, and that's a sequence with a common difference. So if you look at this sequence, 1, 4, 7, 10, 13, 16, 19, 22, 25, you will notice that the difference from each number is 3. 1 plus 3 gives me 4, 4 plus 3 gives me 7, 3 plus 7 gives me 10. So each of the numbers has a common difference of 3. We know from each of the numbers we have to add 3 to get to the next one, to get to the next one. Now let's look at it very carefully. The first term is a 1. So we'll write 1 for the first term. The second term is a 4, but how did we get the 4? Well, we took 1 and we added 3 to it, and that's how we got the 4. How did we get 7? We took the 1, we added the 3, and then we added another 3, and that's how we got 7. How did we get 10? We took the 1, added the 3 to get the 4, added another 3 to get the 7, and then added another 3 to get the 10. And that's how we got to 10. So there's obviously a repeating 3 that shows up here. I can rewrite this slightly simpler by simplifying this 3, which we know as the common difference. The 1 always appears, and we're going to call that our first term. So here is the formula for an arithmetic sequence. We have a sub n equals a sub 1 plus d times the quantity n minus 1. This d is our common difference. Here is our formula for an arithmetic sequence. We have a sub n is the term that we want to find. A sub 1 is our first term. D is our common difference. The n here represents the position of our number. So let's look at this example. We have 3, 8, 13, 18, 23, and I want to calculate the 9th term. I want to use the formula for the arithmetic sequence here. Let's write down a sub n equals a sub 1 plus d times the quantity n minus 1. Now let's look at the very first term. That's 3, so we'll say that's a sub 1, the very first term in our sequence. Now let's look for the common difference. If you check carefully, I have to add 5 to get to here, 5 to get to here, 5 to get to here. So the common difference is 5. We know D must be 5. Alright, so we have everything that we need, and we're looking for the 9th term, so we know N must be 9. So let's plug in what we know into the formula. A sub 9, which is the 9th term in the sequence, is equal to a sub 1, which is 3, plus the common difference is 5, and we're going to multiply that by 9 minus 1. We can simplify this as 3 plus 5 times 8, and this finally simplifies to 43. So we now know that the 9th term in the sequence is 43. For a geometric sequence, we have a sub n equals a sub 1 times r raised to the n minus 1. Again, n represents the position, a sub 1 represents the first term in our sequence, and the r here is known as the ratio. For a geometric sequence, it's different than an arithmetic sequence because we're actually multiplying to get to the next term instead of adding. For a geometric sequence, we're multiplying instead of adding. So let's look at this geometric sequence. We have 3, 6, 12, 24, 48. To get to 6, I need to multiply by 2. And again, to get to 12, I need to multiply by 2. So each of these has a common ratio of 2. We have to multiply by 2 to get to the next term in our sequence. So let's write down the formula. We know a sub n equals a sub 1 times r raised to the n minus 1. Now our common ratio is 2. That's what I need to multiply to get to the next term. And our first term in our sequence is that 3, so we have a sub 1 must be equal to 3. I can plug that into the formula now. So a sub n equals 3 times 2 raised to the n minus 1. Now I could use this formula to calculate any term that I want. If I want the 10th term, I'll just plug in a 10 for n. So let's do that. Let's look for the 10th term. A sub 10 equals 3 times 2 raised to the 10 minus 1, and we get 3 times 2 raised to the 9th. And my solution to the question is 1536. So we can find the 10th term by multiplying by 2 10 times, or we can just use this formula for the geometric sequence. Now we can finally start our worksheet. Let's look at section 1.2 worksheets. We want to fill in the blanks, identify the sequence as arithmetic, geometric, or neither, and 3, where possible, write an expression for the nth term. So please pause the video and try all of these questions on your own. Try to fill in those blanks. Make sure you pause the video and try it on your own. Don't wait for me to do it. I said pause the video and try it on your own. Alright, let's get started. For part A, we have 4, 0, 6. There doesn't seem to be a common difference or ratio here. And then another 4, 0, 6. So there appears to be a repeating pattern. This has to be 6, 4, 0, 6. Then this one must be 4, 0, 6. This is neither arithmetic or geometric because there's no common difference and there's no common ratio. So this is neither. Part B, we have 1, 2, 1, 1, 2, 3, 2, 1, and 1, 2, 3, 4, 3, and we'll have to fill in the blanks. Now, if you look very carefully, there's a pattern. We have 1, 2, 1, and then 1, 2, 3, and it counts back down again. And now we're going to count back up, 1, 2, 3, 4, and we are going to count back down again. So let's fill in the blank. We have 1, 2, 3, 4. Then it's going to be 4, 3, 2, 1. And we're going to start counting back up. 1, 2, and then it can progress further than that. So this does not have a common ratio. It does not have a common difference. So we have a neither case again. For part C, we see that to get to 5, I need to add a 3. To get to 8, I need to add a 3. To get to 11, I need to add a 3. So this must be an arithmetic sequence. It must be an arithmetic sequence. So we'll need to add 3 to get to the next number. 11 plus 3 is 14. Add 3 again, get 17. Add 3 again, get 20. Add 3 again, it's 23. Now we should find a formula for this. Remember, the formula is a sub n equals a sub 1 plus the common difference times the quantity n minus 1. A sub n equals, well, the leading term, or the first term, is 2, so we'll put that for a sub 1, and our common difference is 3, and we'll have n minus 1. Here we want to leave it as just n, because this formula can be used to calculate any position now, And of course, we could simplify this further. You can distribute the 3, and this simplifies to a sub n equals 3n minus 1. So this is the formula to calculate any position of the sequence. Part D, we have 8, 13, 18, 23. Again, this looks like a arithmetic sequence. We have to add 5 to get to 13, add 5 to get to 18, add 5 to get to 23. We'll continue the process. So the next number is going to be 28, 33, 38, and 43. We know this is an arithmetic sequence again. A sub n is equal to a sub 1, which is our first term. That's 8, plus the common difference here is 5, and we'll multiply that by n minus 1. And so I could distribute the 5, and you can simplify this as a sub n equals 8 plus 5n minus 1, or a sub n equals 8. You can simplify this as a sub n equals 8 plus 5n minus 5 using distribution. And now we can collect like terms. The 8 and the 5 makes 3. So our formula is a sub n equals 5n plus 3. You could always check your work. You can plug in a 1 and you'll get 8. If you plug in a 2, you'll get 13. If you plug in a 3, you'll get 18. This one's a little bit different. You can see that the pattern actually subtracts instead of add. So we'll have to subtract 7 to get to 46. 46 minus 7 gives us 39. And 39 minus 7 gives us 32. I could subtract 7 again to get 25. Subtract 7 again to get 18. Subtract 7 again to get 11. Subtract 7 one more time to get 4. This is still an arithmetic sequence. And we'll find a formula for this as well. We have a sub n equals, our first term is 53. Our common difference is negative 7. So we'll put negative 7 here. And we'll multiply it by n minus 1. We can distribute the negative 7. A sub n equals 53 minus 7n plus, since it's negative 7 times negative 1, plus 7. I can simplify this now to our formula, a sub n equals 60 minus 7n. This is our formula. Part F, we have 2, 4, 7, 11. This one's a lot more difficult than the other ones because the pattern is not quite the same. We have 2 to 4. I need to add a 2. From 4 to get to 7, I need to add a 3. And 7 to 11, I need to add a 4. So this is not an geometric or a arithmetic sequence. The ratios are not the same, and the difference are not the same. So for the next one, I need to add a 5. That gives me 16. For the next one, I need to add a 6. That's going to give us 22. We'll add a 7 to get to the next one. That's 29. And for the last one, we'll have to add an 8. That gives us to 37. So we'll have the neither case for part F. Part G, we'll need to multiply by 2 to get to 4, multiply by 2 to get to 8, and multiply by 2 to get to 16. So we can use our calculators now to multiply by 2. I'll get 32, by 2 again, 64, 128, and then 256. This is a geometric sequence because we have to multiply to get to the next one. There's a common ratio. R is equal to 2. That's our common ratio. Our first term is 2. That's a sub 1. And now we can use the formula a sub n equals a sub 1 times our common ratio raised to the n minus 1. A sub n equals 2 times 2 raised to the n minus 1. And I know from algebra 2 I can multiply these. This is an invisible exponent of 1 here. And we'll just have to add the exponents. This is equivalent to a sub n equals 2 raised to the n. So this is a formula. In part H, it doesn't look like it's geometric or arithmetic. There's some other pattern. We'll have to add a 3 to get to 7. Add a 5 to get to 12. Add a 7 to get to 19. So this is neither geometric or arithmetic. It looks like for this pattern we're adding odds to get to the next number. So let's add 9, and then we'll add the next odd 11, add the next odd 13, and then 15. So let's look at our sequence. 19 plus 9 is 28. 28 plus 11 is 39. 39 plus 13 is 52. And 15 added with 52 gives us 67. And for the last one, this is a famous sequence. This is known as the Fibonacci sequence. Let's figure out the pattern. We add 1 plus 1 to get the 2. We add 2 plus 3 to get the 5. We add 3 plus 5 to get the 8. Then 5 plus 8 to get the 13. 8 plus 13 to get the 21. So we're adding the two previous numbers to get the new sequence. So to find this sequence, we'll take 13 and 21 and add them together. 13 and 21 gives me 34. To get the next sequence, I'll have to add 21 and 34. 21 and 34 gives me 55. To get the next sequence, I need to add 34 and 55. That gives us 89. And then finally, we'll add 55 and 89 to get the last sequence, which is 144. This is known as the Fibonacci sequence.